Hi, this is Mr. Mack. In this video, we're going to be talking about the normal distribution. Or sometimes called the normal probability distribution. Now, the normal distribution has been called the bell curve. Now, the graph of the normal distribution looks something like this. And the reason it's called a bell curve is because, to some extent, maybe, it looks like a bell. Now, the book talks about the normal distribution, then it immediately talks also about skewed distributions. Now, skewed distributions are not normal. So let's take a look. See, there's the normal distribution. Now, a distribution that is skewed to the right would look more like this. In other words, can you notice how the middle of the graph is kind of shoved to the right a little bit? There's more data to the right of the mean because it's kind of all gathered up over there. Okay, this is skewed to the right. And obviously, if the data looked more like this, then it would be skewed to the left. It always seemed to me to be strange when I was in statistics class when they talked about the data being skewed to the right, the tail was going to the left, and when the data was skewed to the left, the tail was going to the right. But that's kind of the way it is. So if you have a distribution that's skewed, the distribution is going to look more like this, skewed right or skewed left. But for right now, let's take a look at the actual normal or bell curve. And we're going to just kind of, there's not a whole lot else to say about those at this particular point. Now, what do we know about this? First of all, the mean and the median and the mode of a normal distribution are all the same. Now also, the curve itself is asymptotic with the x-axis. Now, what we do in assigning probabilities is we think of the standard normal curve as this curve with an area between the x-axis and the curve of 1. So in the standard normal curve, we think of all of this region here, even out to infinity, to be equal to 1. And so then if we have, say, this part of the curve has an area of, say, 0.7, we say the probability that a particular data item will fall within this interval is 70% or 0.7. So the area of 1 is kind of important. It's asymptotic. Okay, now there are some basic facts about the normal distribution that, well, I want to say everybody knows, but that may not actually be the point, the truth. I'm going to draw lines down to the x-axis from the normal distribution. And what I'm going to say to you next is that these lines represent units in the area of standard deviation. In other words, this is 1 sigma, this is 2 sigma, and this is 3 sigma units away from the mean. And this is -1 sigma, this is -2 sigma, and this is -3 sigma units actually below the mean. Now, in most of the problems they're going to ask you to do in this particular section, they're going to want you to know that the interval between -1 standard deviation and +1 standard deviation is 68% of the data will fall if this distribution is normally distributed. Between -2 standard deviations and +2 standard deviations, 95% of the data will fall. And then between -3 standard deviations and +3 standard deviations, you would expect 99% of the data to fall. So when they give you information about the standard deviation of the data and the mean of the data, what you're going to need to do is kind of find what these marks are for that particular distribution, and then you'll know from that interval to that interval there will be a that much, with that percentage of the data. So that seems to be about all there is in this particular section about the normal curve. One other thing I will mention is that there is symmetry with respect to the y-axis. In other words, the area under the curve to the right of the mean is 0.5, and the area underneath the curve to the left is 0.5 also. And if you go, in other words, if you were to look at this one right here, this region right here, which is from the mean to 1 standard deviation, would be 34%, or half of 68%. So you can use those things to figure out different parts of the problems also. And that is it. So have fun with those. We're done.